Hi there, I'm David. And if you're in one of my classes and you're looking for some assistance in writing difference equations for an assignment, this is me making up an answer key for assignment 6. I thought I'd run this as a tutorial. So over the next half hour, I'm going to show you how to change a difference equation into a difference diagram and then how to find the step response, impulse response, and response to a specific signal using spreadsheet, PowerPoint, and Excel. Hope you enjoy. Hello, I'm going to walk through how to turn a difference equation into a diagram. I'm going to use PowerPoint to do this. So let's create a new slide. And let's start with our difference equation. So let's hit Alt equals to start typing an equation. And the equation we've got is 5y of n plus 4 y of n is equal to 2x of n minus 5x of n minus 1. Oops, I missed an n minus 1 on the y. 4y of n minus 1. There. That's our difference equation. Now, typically with a difference equation, sometimes we want to write this in terms of y of n. Y of n would be our final output. So if we're trying to calculate the current output, we want everything else on the right-hand side. And usually we don't want the final output scaled. We want it normalized. Normalized is where you change the coefficient in front of the y to 1. So let's do that. I'm going to copy the equation and paste it. And now I'm going to take everything that's not y of n and move it to the other side. So in this case, I've got a plus 4y of n minus 1. I want to take this over to the other side. So I am going to subtract it from both sides. So we could copy it here. All right, minus paste. And we can do a minus paste here. So I'm subtracting 4y of n from both sides. So this 4y plus 4y of n and the minus 4y of n are going to cancel each other out. Whatever I do to one side, I do to the other. So I'm subtracting 4y of n minus 1 from both sides. So now all my x of n represents my current input, x of n minus 1 represents the previous input, and y of n minus 1 represents the previous output. I've got all the inputs and the previous outputs on the right-hand side of the equation, and I've got only the current output on the left-hand side. I've got a 5 in front here. I don't want that 5, so I'm going to divide everything by 5. Whatever you do to one side, the equation you got to do to the other. So let's paste that. Just to show you how this plays out, I'll put a divide by 5 here, put a divide by 5 here. Actually, I should put the 5 here instead. Divide this by 5. And I'm hitting a space before the y of n, because I don't want the y of n in the denominator. I'm going to divide this by 5, and I'm going to divide this by 5. So we've divided everything by 5. Whatever you do to the one side of the equation, you also have to do to the other. Let's paste this, copy and paste. And now let's turn our fractions into decimals. So 5 over 5 is just 1. And the 1 is kind of implied or redundant. Implied is probably the better word. 1 y of n is just the same as y of n. which is what we want. And 2/5 of x is the same as 2 out of 50, or 2 out of 5 is the same as 4 of 10, or 0.4. Minus 5 over 5 is the same as 1. 1 is kind of implied, so let's get rid of that. And minus 4 over 5 is 80%, or 0.8. There, we've rearranged our difference equation, and we've got this in terms of y of n. So we want to draw this as a diagram. So let's take this diagram, or this equation, copy it. Let's paste this into a new sheet or new slide. Paste it as the title here. And now we want to draw this as a diagram. I wonder if there's a good smart art graphic. I think smart art's gonna try and do a wizard for me. This is kind of like a process. I think this is just too much detail. I want to draw this freehand instead. Cameo, pictures. I'm just going to cancel that. That's it. Actually, I'll delete this whole frame. So typically what we want to do is we're going to have an arrow for our y of x, for a y of n, and we're going to have an arrow for our input as well. So let's find an arrow. Here's an arrow. And I'm going to start near the top of the page. So this is going to be my x of n. Let's do another one. This is going to be my y of n. Arrowheads are a little small, but maybe I'll enlarge this when we're done. Let's label the text here. Let's click on shape format. Let's put some text. This is going to be x of n. Let's do more text. Let's add another text box over here and call this y of n. Now, I don't like this because it has put a capital X, a capital Y, because it thinks I'm starting a sentence, which is unfortunate. The capital and the lowercase mean different things when we're drawing these diagrams, so I've converted them back to lowercase. So y is going to equal the combination of these three terms. So we need some sort of box to add or subtract all of these. So what we're going to do is we're going to draw a circle to represent summation. I guess this will work. Do they have a pure circle? Basic shapes. Oval. Dodecahedron. Dodecagon. 7 sides, etc. Hollow circle. And let's go with the oval. We'll keep things simple. Maybe I can hold a shift or a control. There we go. Control is allowing me to draw ovals when my first click was the center point. No control allows me to used corners. First click was a corner. Let's go with center point. So hold the control, and then the shift is going to control whether this is a circle or an ellipse or oval. And that looks like a good size there. Let's line this up. Can I do that by reference? I don't know. Okay, so this circle, and let's change the format of this. We want this unfilled. And let's put some text in there. Can I simply type a plus sign? I can, except it's probably the same color as the fill. Let's go back. Does that work? Shape format. Let's try a white fill and see if the plus sign shows up as a white ink. Okay, good to know. Okay, so the plus sign is going to represent the addition of everything. So we need to add y is equal to 0.4x. We need to multiply the x by 0.4. So we're going to do a triangle to represent multiplication or amplification, gain you could think of. Oh, there's a flowchart processes. I don't see the triangle pointing the right way though. Let's draw a triangle. This one doesn't point the right way either. We'll just have to flip it. Let's rotate our triangle. And shift will lock it into the right angle. And I'm going to type in 0.4 for the gain of this thing. Oh, and it's put it on an angle for me. Oh well. So we're going to multiply our x of n, our current input, by 0.4. And that is going to get added to it snaps. Nice. That's going to get added to our signal here. So our x is going to come in, get multiplied by 0.4, and then get added to everything else. One of the other things we need to add is a negative copy of the previous input. So this thing. Let's do that. So let's, to show a previous input, we're going to add a delay. Delay is going to be a rectangle. Let's take our x of n. We'll draw a rectangle to represent a delay of 1. And I will type in delay here. And let's draw an arrow. Ideally from the midpoint or from somewhere on this x to our delay. So our signal comes in, gets multiplied by 0.4. It also comes in and gets delayed by 1. So this is kind of like got a little bit of memory to it. And then we want to multiply that by -1. So let's draw another triangle. Go to my shapes, find my triangle. -1. So this is how much amplification is. Hold down shift to lock that in place. Let's line it up. And let's draw an arrow. So that's going to start here and end up here. And let's draw another arrow. Oops, let's draw a dogleg arrow. Oh, that worked nicely. Auto-magically even. Although I'd kind of like the endpoint to be there. There we go. And maybe I'll move this around. So it ends up with. Surprised it didn't line up with that. There we go. That looks nice. Let's line this up. There, that looks pretty. Okay, so I've got my x of n comes in, some sample gets multiplied by 0.4. It also gets delayed. One sample, and whatever the previous sample was is going to be multiplied by by -1. And I'll see to minus 0.8 of the y value. Now let's hook this y up to the circle, and there's no arrowhead here, so this is the output. Everything with an arrowhead is going to be an input to this addition, and everything without an arrowhead is going to be result. So I need a minus 0.8 of the previous y. Let's take our delay, and let's hold down Control. Oh, it's got the arrow with it too. That's nice. I thought it had the arrow with it. I guess not. So by holding down Control, we can drag a copy of things over. Let's do that. And we might want to multiply this by -0.8. So let's drag this triangle over about here. Here's the enlarged picture. I forgot to zoom out and show this to you. So here it is, enlarged full screen, so you can see it in hopefully better detail. Stay tuned. We're going to open this up in Excel and copy the equation in and calculate okay, let's calculate the impulse and step responses for this diagram. So I'm going to take the copying and pasting from my spreadsheet, or from my PowerPoint at the moment, and let's paste some text in here. So I'm going to use the apostrophe first, and then I'm going to paste what was on the clipboard. This is a text representation of the equation, and we want to take this equation and turn it into numerical values for the impulse and step response. So let's change the name of this sheet here to, let's rename. This is going to be impulse. While we're at it, let's, actually I'll duplicate it later. It's going to do a couple other responses, but let's start with this, and then we can save ourselves some work. So n is going to be my sample number. X is going to be the input value, and y is going to be the output value. Now I happen to see here that we've got a delay of 1, so we need to use current value of n and previous values of x and y of n. So I'm going to give myself a little room to work. Normally we start calculating y of n when n is 0. But we need a little room to work. So I'm going to put 0 here, 1 here, 2, and so on. But we need to give ourselves a running head start, because our equation, we want to calculate y of n, that's this box here, but it's going to depend on previous boxes. And so to make the equation work, we might assume that the previous inputs were 0. An impulse has a value of 1 only when n is 0. Sometimes you'll see this represented as a, actually I'll write this as a delta. I'll use a lowercase d instead of the Greek letter delta, simply because this is a cell and not fancier equation editor. So this is what an impulse signal or input looks like. It's 1 only when n is 0. Now we want to calculate our outputs. You see here up at the top that y of n is equal to 0.4 of the current value of x. So this is equal to 0.4. And we're going to use the asterisk here as that's what Excel treats as multiplication. Not to be confused with convolution. It's going to equal this box here. So my current output is equal to 0.4 times my current input. Current meaning on the same row. Then I'm going to subtract the previous input. So you see here where I've got minus x and minus 1. I'm going to subtract the previous input. Let's go over to the previous input. And then finally, I'm going to subtract 0.8 times the previous output. That's this box here. And when I hit equals or enter, it will calculate this for me. And now I can drag and drop this down, and it will copy and paste the equation for me. And if I edit the equation, you'll see all the boxes have copied relative to the y box. And of these 4 boxes, the bottom right is what I'm trying to calculate. So the bottom right box is equal to current input, which is the bottom left, and previous inputs and outputs. Previous input and previous output, the top left, top right. Now, I'm actually doing this as a marking key or assignment key or answer key for an assignment I'm about to mark. So I'm going to copy and paste this down. We need the first 8 values. So that's when n is from 0 to 7 inclusive. And I can copy and paste my zeros for my input. And here's another trick. I can double click on the bottom right corner and it will copy and paste. Now chances are my students are going to round off to 3 places, so I'm going to highlight these boxes and choose to change the decimal point, number of decimal points. There. And let's zoom out so we can see everything. I'll hide my ribbon bar so I've got more room. Double click will do that. There we go. There is my difference equation up at the top. My inputs, and actually I can now say that because this is an impulse response, y happens to equal h of n. If I put an impulse in, a delta, I get h, the impulse response, out. Okay, let's repeat this for the step response. So I'm going to move or copy. I'll create this at the end, create a copy at the end, and I'll rename this to step. And a step turns on when n is 0, and it stays on. And you can see that this is automatically calculating for me as I do it. Now, we're going to change this. The letter we use to represent the step is the letter U. So U by itself looks like this pattern. It turns on when n is 0 or more specifically, when the stuff in the boxes inside the square brackets is equal to 0 or bigger, U produces a 1. And since this is a step coming in, the output we can also call, or also known as step response S. So the step response, and you'll notice the formula here is the same as we had for the input, for the impulse response. So the beauty of Excel, you can copy and paste these sheets, and it handles this nicely for us. Let's do one more. Let's copy and move to end. And in this case, I'm going to rename this as custom. So in this case, we've got an equation for x. So this is no longer u of n. This is actually rather long-winded. This is a delta n minus 2 delta n plus a 4 delta n minus 3. And get rid of the y there so you can see what this looks like. Sorry, did I put a minus sign? Yes, I put a minus sign for the 2. So what that means is I've got an impulse. So that's going to look like this. And then I've got another impulse. Oops, I forgot my minus 1. I need a delay in there. So we have minus 1 here. So I've got a delay here, 2 delta n minus 1. So when n is 1, the stuff inside the bracket for the second term will create a 0. And 0 will turn on the delta, the impulse, and create a minus 2. So when n is 1, x is going to equal minus 2. And lastly, when n is 3, let's go down 1. When n is 3, 3 minus 3 is 0. 0 inside the square brackets turns on the d and creates a 1, the impulse. And 1 times 4 gives me 4. So when n is 3, x will equal 4. Notice I'm still using the same equation. The current output, the bottom right corner, is equal to the current input, the bottom left corner, times a factor, plus or minus the previous input and previous output times their respective factors or coefficients. So there you have it. And what would we call this box? I would just call this y in this case. If I double click, I can change the width of these things. So in this case, y of n, my output, when x is equal to this mess, y is going to equal this. Let's tidy this up. We'll do a merge and center on this.